This video will cover the Geometry Common Core exam from June 2015, questions 29 through 31. Question 29 says, in the diagram below of circle O, the area of the shaded sector, AOC, I know it's hard to tough, this is a scanned-in copy, but that's AOC, is equal to 12 pi inches squared. And the length of the radius OA is 6 inches. Now it didn't say the word radius, but if we go from the center to the outside, that is a radius. Determine and state the measure of angle AOC. So our goal is to find that value of, say, x. Now there's two options for doing this. One option requires you to memorize the formula for the area of a sector. This formula is not given on the reference sheet, and it's kind of a lengthy formula to memorize, but it's related to the area of a circle itself. So area of a sector is equal to n over 360, where n is the number of degrees out of 360, times, not equals, times pi r squared. So pi r squared, remember, is just your area formula for a circle. And then I want only a portion of it, which is why we have to take n and divide it by 360. Now they told me that the area of sector AOC is 12 pi. So here we have 12 pi equals, now n again is the number of degrees in the angle. And I don't know what that is, so I'm going to call it x. X over 360 times pi r is now 6 squared. So we have to do a little bit of simplifying before we can find out what x is. 6 squared now turns into 36. So I have 12 pi equals x over 360 times 36 pi. So if I simplify a little bit more, I'm just going to extend my fraction bar. I now have 12 pi equals 36 pi times x divided by 360. So because we have a fraction on the right side, I'm going to make the left side a fraction by putting it over 1. So when I cross multiply, I still have 36 pi x equals, now 360 times 12 is 4,320 pi. My goal is to get x by itself, so I want to divide by 36 pi. And notice here that I'm putting it in parentheses. If you forget the parentheses, then the pi's won't cancel nicely. It'll end up being multiplication by pi instead of division. Here on the right side, I have pi divided by pi cancels. On the left side, 36 pi divided by 36 pi cancels. So now I have x equals whatever this division gives me. 4,320 divided by 36. It ends up being 120. So x, or the measure of angle AOC, is 120 degrees. So that's option 1. If you think that's complicated, then I think the second option will be easier. Honestly, I'm not sure which would be easier because both of them require a little bit of work. Some students think about the formula as the easiest option. Other students like to think logically about this problem. We know that the area of the circle is equal to pi r squared. And we know that the area of the sector is equal to 12 pi. We can first calculate the area of the circle by using the radius. So area of the circle equals pi times 6 squared, or in other words, 36 pi. And I know that I'm using up a portion of that circle. I'm using up 12 pi. So what we can do is set up a proportion here, where we have the circle over the sector, we'll say. So the circle's area is 36 pi. Over the sector's area is 12 pi, which should be equal to 360 degrees, that's how many degrees are in a circle, over x. I don't know how many degrees this angle is to make up 12 pi as the sector area. So when I set up this proportion, I can cross multiply and solve. So I have 12 pi times 360 equals 36 pi times x. When we do a bit of division by 36 pi, the pi's cancel. The 36 pi's cancel on the right side and the pi's cancel on the left side. Now I have 12 times 360 divided by 36 equals x. I don't have a calculator on hand, but I know that I can do this math in my head. If I think about 360 divided by 36, that should leave me with 10. So I have 12 times 10 equals x. 12 times 10 is 120, just like what we got before, but this time we just did it in a slightly different way. Again, if you have a calculator, you can certainly type this all in. So again, the final answer for question number 29 is 120 degrees. Number 30 says, after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why the triangle ABC is congruent to triangle A prime, B prime, C prime. Remember that congruent means same size and same shape. So if I were just to think about this on a graph, off a graph, it doesn't matter. If I take a triangle ABC and reflect it over a line, that's just a flip. And when I flip a triangle, I keep the same size, same shape, but I have to actually use properties of this reflection that help me describe why the triangles are congruent. So we can say something along the lines of a reflection is a rigid motion. Which preserves distance. Remember, rigid motion always preserves distance. Therefore, the side lengths are equal, so the triangles must be congruent. And if you were to think about this, each pair of corresponding sides are congruent, and so if we mark this up with S's and A's, we have side, side, side. You don't have to state that they're congruent by side, 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 but it's true that they would be because side length is preserved, or distance is preserved in a reflection, because it's a rigid motion. Number 31 says a flagpole casts a shadow of 16.6 meters long. Before I read any further, I'm going to start sketching. A flagpole casts a shadow that is 16.60 meters long. Tim stands at a distance of 12.45 meters from the base of the flagpole. So here's the base, that green dot, and Tim is 12.45 meters away from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole shadow. If Tim is 1.65 meters tall, determine and state the height of the flagpole. So my goal is to find out the length of the flagpole, or in other words, x. Now this looks like a picture that's familiar to me if I connect the edge of the shadow to Tim's head to the top of the flagpole. So this looks like a picture like this, where we have 1.65 x, 12.45, and the whole is 16.60. These triangles must be similar because Tim and the flagpole are parallel. So these triangles are similar. So first I want to subtract to find this piece here. So I'm going to take 16.60 and subtract 12.45 to give me 4.15. So I have 4.15. I'm just going to copy it over onto the other triangle as well. Next, I'm going to think about setting up a proportion. Again, because these triangles are similar, the sides are in proportion. Oops, proportion. So here, I'm going to choose to do top over whole. Now, this triangle's on its side, so the top is actually the 4.5 over the whole, which is 16.60. 4.15 over 16.60, which is equal to, now I have to do this piece here, 1.65 over the whole bottom piece, x. We can cross multiply to solve here. So we have 4.15 x equals 16.60 times 1.65. In the calculator, that gives us 27.39. Divide by 4.15. So then x equals 6.60, and then there's more decimals after that. But we are asked to round to the nearest tenth. Tenths place is the 6 after the decimal. Looking to the right, the 0 tells me to keep it the same. So the height of the flagpole is 6.6 meters.